I want to speak about sustainable life on Earth and the engineering schemes associated with that. But I want to start with this first chart to really help define the problem. Climate scientists have made it clear to us that greenhouse gases are a major threat to sustainable life on Earth. Moreover, they are leading to a slide into a climate disaster, and it is important now that we consider how best to address that and how we bring the changes that are needed in an efficient way. The title of this is Engineering Distinction, but it really relates to the fact that since the start of the Industrial Revolution 200 years ago, progressively people's demands have led to the situation we have today. We have a better life quality, we're very happy with it, but unfortunately it has the byproduct that from almost no impact on the climate, we now have something like 50 billion tons of CO2 equivalent going into the climate every year with reduced resources to absorb that. So all that we now generate is tending to go into the atmosphere, making a bad situation worse. We're already seeing some significant impacts in terms of flooding and extreme weather events. There is no magic bullet. There is no vaccine. It's people's behavior that has got to be addressed. And we have to find the way that people want to make that change and at the same time address the threats that we're facing. So we're going to speak about that. Hans Rosling, who is a Swedish physician and academic, has really drawn our attention that we shouldn't be thinking in terms of the rich and the poor, because most of the people are somewhere in the middle. He estimates it to be around about 71% are in this middle income bracket. So on this chart, and it's a very important chart, we'll be using it again in terms of our logic for how we progress. But the low income people are in extreme poverty, living on less than $2 per day. The middle income covers a range from $2 to $32, and the richer side of it all, the extreme, is above $32 a day. But the important point, Hans Rosling and the Gapminder people have drawn our attention to, is that everyone wants to move from the left to the right. And he's also now plotted this second chart, which shows greenhouse gas emissions. And here we see that the richest are responsible for extreme amounts of emissions. And as we move from right to left, for each step we take on this chart, we halve again, and so on and so on and so on. And what we really are addressing in this talk tonight is we really want to see those 8 bars on the right either disappear completely or certainly be down in the 1s or 2s. But at the same time, we have to make that end desirable such that people will want to make that change. We can either do very little about it and leave things as they are, in which case we'll progress steadily but surely into an ever more extreme environment, which will be unpalatable to many. So we really do have to address this. And the tools that we have really are the people themselves, because we're now in a position where we have huge diversity of people. Within that, we have a great range of skills. We have superb communications. Whenever we want, we can speak to someone in real time, the other side of the world, despite time shifts, language differences, and so on. And indeed, we regularly do. In our family, every Sunday at 12 to 1 o'clock, we meet with family and friends and even go for walks with them in Shanghai or seaside resorts in China. So communications are now fluent, which does mean that we have the opportunity of working together once we know what to do and we know that it's to our advantage. The first item we need to address really is clean energy. I think we all know well about, particularly about UK activities in terms of wind turbines. 40% of Europe's wind crosses UK territory and is a strong contributor. We also have solar panels, and particularly solar panels in the hot regions, hot desert regions of the world. These are now contributing, when online, something like 1 kilowatt hour per penny spent. So they become very affordable. But none of these things is of real value until they're backed up with renewables. And there are 3 renewables that are important. The first is batteries, which makes sense for short-term use, such as short-range aircraft, such as motor cars and so on, and even backing up the grid. But perhaps the most important one of all is to convert that low energy density energy into a more useful form, particularly in the form of hydrogen. But there's a third one we need, and that is we need a carbon neutral, high energy density liquid fuel. Now, in terms of the electricity supply, we've not only got to meet the requirements that we have today for electricity, but if we're going to phase out all fossil fuels, and also our industrial processes are going to be more electrified, then we have to think in terms of a massive increase in renewables, and perhaps renewables by themselves are simply not enough. And this is where small-scale nuclear becomes very important, such that we can achieve resilience and meet the lights on 24/7 throughout the year without interruption at an affordable price. The importance of small-scale nuclear is that the principal driving force in the terms of the cost we pay for each unit of electricity is in fact the cost to build the plant and the time it takes from making that spend to the time when we're generating revenue. And so with small modular nuclear reactors, where much of it can be made in factories, we have the opportunity to reduce the cost and to reduce the time it takes from a spend to being online. Serious thought has been given to capturing carbon. This is a rendering of carbon engineering from Canada. It's their idea of how they would capture something like 1 million tons of carbon dioxide each year for a cost of something like $100. But when you think we're talking about capturing 1 million tons of carbon, that compares with the 50 billion that we're putting in from the activities caused by people's desire and people's ability to spend on what they see to be desirable. So it really is interesting. It has some relevance, but it's not really a major form of addressing the problem. We really have got to do it by changing the way we behave and, in fact, make sure that that is so desirable that people want to make that change. Then it becomes investable. It will attract the investment that's needed to sustain it. I want now to speak about transport. We make many journeys that we need no longer do. We have the means of moving data and funds from wherever we are. So many trips, like commuting daily from the countryside into the central office, leaving at home some very smart IT equipment, often to go and work in a central office to connect with the rest of the world with inferior equipment, because that's all that the company can afford. If we want to retain the motor cars, we really have got to think in terms of making all the cars clean. And indeed, we need to be thinking about whether we really need to dash to work in a big diesel engine Range Rover, or should we have something like this? For example, it's a single seater, it's highly visible, it's fully air conditioned, it's trustworthy, it's got all the in-car entertainment, and it can accelerate into fast-moving traffic and run with that traffic. But at the same time, it's battery powered and it needs only a small battery, so it becomes very affordable. And it represents important opportunities for new business to produce the things that many people would find very acceptable. Big trucks have something in common in a way with commercial airplanes, in that they have a weight limit. And what the truckers have explained to us all, they made it clear that they want to be able to match the diesel in terms of productivity, and they also want the same distance between refueling stops as they have with the diesels. And the only way they can do that is by fueling using liquid hydrogen, which has a very high energy density and is accommodated within a reasonable volume. Quite a big one, but still a reasonable volume. So there is a formal program which is called H2 Accelerated, as you can see on the slide, and it's very much focused on achieving what the trucks do today and to do it with zero emissions. The other thing that has become possible is that with high density batteries and with high thrust to weight or power to weight ratio electric motors, it becomes possible for battery only small aircraft like this vertical aerospace designed in Bristol by the vertical aerospace company. It's called VAX4. It's a four-seater. It makes use of the vector propellers. You can see the four on the front. There are two at the rear. And when it's in cruise flight on the wing, the two rear propellers are shut down and put into a low drag configuration, so that for much of the journey is done efficiently on the wing. But this only makes sense when the airplane is small, when the flight speed is low, and when the range is also small. So we're talking about up to 200 miles an hour, up to 200 miles or thereabouts. Many of us will know about Project Fresson, which is a program based upon the very popular Britten-Norman aircraft. It's a 9-seater. It's widely used in small fields, remote areas, across water journeys. And in this particular case, and it's been the conversion of the aircraft is taking place now, not far from where I'm speaking to you from, at Cranfield University. And you'll see that the piston engines have gone. The propellers are driven by powerful electric motors. The pods under the wing contain high pressure gaseous hydrogen, which feed fuel cells. And so this aircraft has got a very wide range of capability and is capable of flying those 9 passengers with zero emission, short field performance with a very wide range of applications. And this is another example that makes sense. I think we are likely to see a follow-up out of Germany based on the 228 aircraft with about 19 seats, but it's unlikely to go much further, although there are some plans to go as far as 70 seats, but almost certainly that will require liquid hydrogen in order to get the fuel on board in a sufficiently small space to make sense for the economics of the airplane. I'm now going to jump to what might we do for long-range zero-emission aircraft? And if we really want to get to that end, we really have got to think about a radically different shape. And I think many people will know of the blended wing body. This is in fact a free flight model by Airbus called MAVERICK, as you can see. It has two very efficient high bypass ratio direct burn of hydrogen, essentially of liquid hydrogen, but it is in the gaseous form by the time it gets to the engines to form the propulsion. And whilst you may have seen airplanes like this with cinema-style seating, in truth, you need to be thinking about a central tube that's pressurized for the passengers and a couple of panniers, one each side, which will be the fuel tanks required. And they are quite voluminous. If we're talking about 350 seats, we are talking about a volume in liquid of something like 500 cubic meters, and that's an awful lot of volume. Studies done by DLR in Germany have indicated that the return to commercial aviation in big numbers is likely to take place for ranges of only up to about 4,000 kilometers. Now, the A350 Airbus dash 1000 is aimed at something like 4 times that. So if you do the sums, that aircraft at max takeoff weight weighs 300 tons, and it has the capability of carrying 127 tons of jet fuel. But if we now think about liquid hydrogen, or hydrogen in any form, the energy density of that hydrogen is almost 3 times that of the jet fuel. And when you also allow for the fact we're only flying a quarter of the distance, we quickly see that the 120 tons of jet fuel can reduce for the shorter range to a mere 10 tons. Now, depending on how much we need for all the systems, for the well-insulated tanks and the heat exchangers and everything else that goes with a hydrogen-powered aircraft, what we find is that 10 tons, before you allow for the insulation, that 10 tons occupies a volume which is comparable to the volume for the jet fuel for the longer range. But in fact, if you're no longer going the longer range, you don't need to feed the passengers so many meals. The long-range aircraft may have a flight time of 18 hours, 19 hours even, whereas our flight time will be, roughly speaking, a quarter of that. So, in fact, we have available space, and what we might see happen is, in fact, somewhere at the rear of the aircraft would be the hydrogen fuel tanks, which would supply the liquid through into the wings, onto the engine, which would arrive in gaseous form to be burnt directly in engines, not unlike, there's no shying away from the fact that the challenge is severe. But when you compare it with sustainable aviation fuel derived as a manufactured product, we really are talking about something that is much less costly and certainly gives us a performance advantage. And I feel very confident in predicting that aircraft in the not too distant future, possibly as early as 2030, but certainly within the 2030 to 2040 timeframe, we will be flying with liquid hydrogen. It is the right way to go. With all this increase in air traffic, the wonderful people at Cranfield have, in fact, not only invented, but built for their own airport a digital air traffic control system. And indeed, in typical ways in which they work with industry and the operators, this system is now installed in several international airports, including London City Airport. And it's important because with the capability now of having a much increased traffic near the airport, we really have got to have a superb and very safe way of handling that increased traffic. I want to speak now about food and agriculture. In fact, my very presence here tonight is in thanks to one of these fine animals who devoted and gave me my mitral heart valve, which is why I'm here today. The important point here is that meat in particular, if we look across the world, our meat consumption rivals that or exceeds that of all the world's 1.3 billion cars. It's a problem with methane rather than carbon dioxide. And methane, although people tend to think of it being only 23 times as bad as carbon dioxide, the real truth is, with the short time frame that we've got to address this problem of the avoidance of taking a hit on sustainable life and climate change, we really have got to work very quickly. And it's important that we deal with it by starting to look at, first of all, trimming our diet. We knew that in World War II, we were able to deal with an improved quality of life by rationing and taking on board less meat. But for those who really want to have the meat, then we now know and understand how to make cultured meat with the right sort of texture and the right level of taste. The trick is that we do have to make it affordable and desirable, and much effort is going on to that. It's supported with some very big name investors. But the next point I want to move to, Dave, is I want to just talk about vertical farming. The picture in front of you is Dave Scott, who is the founder director of the first vertical farm in Scotland. But prior to that, we had the Jones Food Company that is working closely with the supermarkets, and it gives the opportunity of growing food plants and getting the right quality. We don't need to think about pesticides. We can reduce the amount of fertilizer. We can use 95% less water. We can match the output to the demand profile from the supermarkets. We can deliver fresh produce at the till, so to speak, in the supermarket that is still living and growing right up to the point of sale. I also want to speak about houses and communities. The developers have made it very, very clear that they can in no way, by conventional methods, meet the demand for houses. We really need to use new technology. And there are three ways really in which we can do this. Here is an example which was brought about by a charity in the United States. It's a 3D printed home. It's 500 square feet. It has 2 bedrooms. It has a lounge, a kitchen, a bathroom, a veranda, and the process gives rise to very affordable homes. Initially, it was done in quantity in Tabasco, in Mexico, for homeless people, but we've seen examples of it being rolled out with far grander houses, and it gives us great freedom to produce high-strength, well-insulated buildings. If you were to take a look through the wall, you'd see there's a nice, delicate Warren girder type structure that gives it its strength, but also gives insulation. The other alternative is cross-laminated timber. And indeed, this is the big factory up in Yorkshire. There is another alternative of that, which I've not shown in the picture, but the metal fabricated version of this has the opportunity to get a high level of insulation. It's really time for action, and we have to think about what we want to do. I think that's very clear, and we know we've got to do it at grand scale right across the world. And it's very clear that unless the people want it, it won't happen. If the people do want it, then the investment will come. And so the process that's got us to where we are today, with desirable standards of living for those towards the right end of the diagram, we can use the same process. Now we know what we want to do that has much lower emissions, but gives us a yet better quality of life. And we can apply this process to all of our activities, whether it be transport, homes, energy, or our need for food and agriculture.